Hi everyone, I'm Gregory, a senior software engineer and the team lead of the cross-chain team at the DFINITY Foundation. And today I would like to show you how a smart contract on the internet computer, also called the Canister, can control assets on the Solana blockchain. So Solana is one of the leading blockchain in terms of trading volume in the last month. And by controlling assets on the Solana blockchain from the internet computer, you can tap in that vibrant ecosystem and also leverage existing integrations like with Bitcoin, with Ethereum, and other EVM chains. So today what I would like to focus on is basically three things. We're going to deploy a smart contract on the internet computer, and that smart contract is going to do three things. One is going to read the state of the Solana blockchain. So for example, reading the account balance on Solana. And second, we're going to write on the Solana blockchain, meaning send transactions from Canister. So first, we're going to start easy by sending some SOL, which is the native cryptocurrency on the Solana blockchain, from a Canister to a Solana address. And last, we're going to show how to send also an SPL token. So SPL is like the fungible token standard on Solana, such as USDC, from a Canister to the Solana blockchain. So now I'm inside an IDE with two windows. And basically on the left, this is going to play the role of a Solana user, so which has in particular, for example, the Solana CLI tool installed. And on the right, this is going to play the role of someone interacting with a Canister on the internet computer. So as set up on the left, I need to have the Solana CLI tool installed, some somewhat recent version of it. And okay, this can remove. And then for the purpose of the demonstration, we're going to create a new key pair. Right. And for the configuration on the Solana side, what we want to check is that we are on DevNet and the commitment level we are looking at is confirmed. So for testing purposes, we want things to go fast and we are not so worried about potential forks and whatnot. And that's the Solana address controlled by the Solana CLI tool. So on the right-hand side, we're going to set things up also. So basically, you need your standard Rust Canister development toolkit. That means you need Rust, you need DFX, the command line tool to interact with canisters. And also, basically, we are going to run through the basic Solana example that we have, which is available in that GitHub repository. And then you can check that example. So there, again, I have some DFX version installed, which is somewhat recent. And we can check that we are on the right path. So now for the purpose of that demonstration, we're going to deploy that Canister. So basically a brief overview of what that means. So on the left-hand side, I have the basic Solana Canister. So that could be your dApp that you are developing. And that's going to interact with the Sol RPC Canister, which is already deployed on mainnet. So that's basically your building block to interact with Solana. And behind the scene, that building block is going to query multiple providers to have no single point of failure to reach the Solana blockchain. So I already created an identity called admin to deploy that Canister on mainnet. And now I'm going to deploy that basic Solana example. So if you do this the first time, it may take a bit longer. But while it's deploying, we can go through the initialization arguments. So here I'm also at commitment level confirmed. For threshold signature, I'm going to use a key which is deployed on mainnet, but for testing purposes, so that it costs a bit less cycles. And I'm targeting the Solana DevNet network also here. And this is the address of the Sol RPC Canister on mainnet. This one is not the production Canister, it's a Canister controlled by our team, but it's still on mainnet on the fiduciary subnet. So in short, this is as production ready as you would get. We are just dealing with Solana DevNet and not mainnet. All right, my Canister is installed. Let's check quickly the status. It should be running, and I should have also some cycles to play with. And the last thing we're going to do is now to create a new identity on the internet computer. and that's going to play the role of a user interacting with your dApp. Right, so this is my principal, and I'm going to save it in some environment variable for later use. And that's the end of the setup. So now we're going to start the first thing, which is reading the balance of a Solana address. So here, for example, I can do it with the CLI, right? That's easy. I should have absolutely 0 because this is a new address. And I also can do it via my canister. So for this, I'm going to save that Solana address also in an environment variable for later use. And basically, my basic Solana example exposes a get balance endpoint, which is going to call the get balance endpoint of the SolRPC canister. And there, it's also going to return 0, which is what we expect. So now you could see maybe one interesting thing is that the call on the left is much faster than the one on the right. And why is that? And basically on the left, what we are doing is just one call to API devnet.solana.com. So we are fully relying on the results of that endpoint. And on the right, basically, we can check what happens by looking at the logs of the SolRPC canister. So this is a fresh address, and we can search for that address. And what we see is basically we're going to see 3 hits. And that's because by default, the SolRPC canister is going to create 3 different providers. So in that case, Alchemy, DRPC, and Helios. And each such log entry for one provider corresponds to an HTTPS outcall. And that means since our canister is deployed on the fiduciary subnet with 34 nodes, that means actually one HTTPS outcall means 34 HTTP requests and then doing consensus on top of that. So we are doing this 3 times. So in total, we are basically doing 100 in the order of 100 HTTP requests distributed globally, targeting independent providers, and all of that to avoid a single point of failure. Okay, so I have 0, so that's not much fun, but because we're on DevNet, I can get some tokens by requesting an airdrop. All right, I have a transaction, which is now confirmed, and so now my balance should be updated. And if I call again via the canister, the balance should also be updated. All right, and one thing to note is that here the result returned by the canister is in the smallest denomination of Sol, called Lamport, and where the conversion rate is 1 billion Lamport equals 1 Sol, so Sol has 9 decimals. So that's basically the same number, just represented differently. And that's the end for reading the balance. Now that we know how to read, that was easy, but the fun starts when we can actually write on another blockchain. And here the key feature that we're going to use is threshold schnorr, which allows a canister to control an ED25519 public-private key pair, which is the signature scheme used by Solana. So if I were to summarize in like 3-4 bullet points what threshold ED25519 is that basically each replica in the subnet holds the share of a secret key, and that share allows a replica to create a signature share for a given message. And those signature shares are going to be gossiped around. And once a node has enough signature shares, it can combine them to create a perfectly normal looking signature for that message. And what's important is that at no moment is the secret key reconstructed anywhere. So what that means is that our canister controls an ED25519 public-private key pair, and it can use that and key derivation to derive a whole tree of key pairs. And so the standard way to use that is to create, for example, key pairs for each user on internet computer, where user is identified by his principal. So basically, I can now ask my basic Solana canister, what's my address from my principal, which is this one. So I'm going to save that one also in an environment variable. And also on the left. All right. And so I can also ask what's my balance for that address. So that address is controlled by the canister and is derived for my principal. And of course, it's 0 because I just created the principal. So I don't have any funds, but I have some funds on the left. So what I can do, since it's just another Solana address from Solana's point of view, I can do a transfer of the airdrop, of some of the airdrop I'd received to that new address. So I'm going to send, for example, 0.1 Sol. So now the balance should be updated and I should have 100 million lamp pods. Okay, so now now that we have some funds to play with, we're gonna send a transaction from my canister. So that canister was a send sol endpoint, and here we are requesting to send a transaction using funds controlled by the canister, and where the address used is derived from my principal. We're gonna target the address on the left, so the one controlled by the Solana CLI tool, and we're gonna send one lamp pod. Right. And now I just got a signature. So this corresponds to the signature of that transaction, which is also used by Solana for the transaction ID. So we can check that transaction in an Explorer. So here I'm on Solana Explorer on DevNet, and I can look up that transaction. Right. And so what we should see is that basically we have a transaction with the change of balances, and the sender should be the address controlled by the canister. So that should be that one. Right, so that matches. So that one is also the fee payer, so it's the one sending the transaction. And the receiver should be the address controlled by the Solana CLI tool, which is this one. Right. So basically, this looks like a perfectly normal looking transaction on Solana blockchain. There is no, from it, you cannot tell that it was issued by a canister on the internet computer. So one thing to note is that here, in order to build a transaction for Solana, one needs to have a fairly recent block hash in the transaction. That's the way Solana avoids the double spending problem. And here with HTTP out calls, it's a bit tricky. So please check the code for more details. We are using some heuristic there to get maybe not the most recent block hash, but recent enough so that it works for transactions. Okay, and that's the end for sending Sol. Now in the last part of this demonstration, we're going to focus on a particular SPL token, which is a fungible token stored on Solana, and we're going to use a USDC on DevNet. Which is available here. So we can check it also in our Explorer. So that's USDC. And so I'm going to save also the address in some environment variable. And one thing to note is that the way Solana works with those tokens is that basically we need to create an associated token account for both the receiver and the sender before sending any such tokens. And that's because those associated token accounts are needed to store the user's balance for that token. And they are derived using the user's account and the token address. So basically, for each user, if they have different tokens, they have different associated token accounts. And we can create it on the right-hand side by calling the create associated token account endpoint. And on the left-hand side, I'm also going to store the USDC DevNet address in an environment variable. And here I can use the SPL token command line tool, which also comes installed with Solana CLI to create an associated token account for that address. So once I have an associated token account on the canister side, I can basically use a Faucet to request some USDC. So here is the address of my associated token account. So I can go to a USDC Faucet, which is provided by Circle, and request some USDC. Wait, that's the wrong address. Right. Okay, so I should have now 10 USDC in my associated token account. So let us check the balance, right? I can see here in the transaction that indeed it got credited by 10 USDC. So I can also get via the Canister my USDC token balance, which should be 10, but since USDC has also 6 decimals, it's going to be written as 10 millions. Right. Okay, so now that I have some funds to play with, I can send a transaction. And here we can use the send SPL token endpoint of my Canister. So again, it's going to use the address controlled by the Canister and derived from my principal. Are we going to use the USDC DevNet address or USDC token? We're going to send it to the address controlled by the Solana CLI on the left-hand side, and we're going to send 1 USDC, which is with 6 decimal corresponds to 1 million unit. Okay, this takes a bit of time due to the multiple calls that we have to make, but at the end, I have another transaction that I can look at in my Explorer. Right, and so what we should see is that basically my associated token account for USDC, which is this address, was debited, so by 1 USDC, and the receiver should be my associated token account on the left-hand side, which is that address, and this one should have received 1 USDC. So we can also check the balance here on the left and on the right. So we can see, okay, on the left, indeed, I received 1 USDC, and on the right now, I should be short of 1 USDC. Yes, with that amount. All right, that's the end of this demonstration. I hope you enjoy it. Please check out also the repository for additional examples. For example, how to use durable transactions inside the Canister, and for additional documentation and examples. Feel free to reach out to the forum if you have any questions. Thanks a lot for your attention.